we are a little furry mammal, and we've had our intelligence conferred on us, very luckily, giving us the ability to deliberate.
Yeah.
But I don't think we can take it further than that, but I'm open.
Simon worked as a survey researcher and was exposed to the power of probability theory, which led to a degree in statistics and economics, introducing him to the world of large-scale dynamical systems. After reading Solzhenizin, he decided to obtain a law degree, move to the US, and open a law office. He bought and now operates a farm, where he has developed a lay interest in the deep laws of reality. He was a South African national polocrosse champion and has a squash court in his barn. Welcome to the James Wiles podcast.
Hi, Simon. Thanks for joining the podcast today.
Pleasure.
I wanted to ask you a series of questions and just get your take on a few things.
Okay.
And I wanted to start off with your interest in the meaning of physics, or the meaning behind reality. I know you spent a lot of time reading and recently doing a little bit of writing on it. What actually got you interested in that field?
Well, physics and reality are not the same. I got interested in physics because if you are looking at reality and you have any remote knowledge of physics, you have to go to physics to seek some of the patterns of nature. And so it really started with this view that the idea of something arising out of nothing, like a Big Bang or equivalent, either in this universe or the next, is preposterous. It runs totally contrary to any logical ruminations of a human mind, and I'm not prepared to give up my logic, and I therefore thought there has to be an alternative. And to me, the alternative is quite simple, and it's almost impossible to avoid, and that is that the rules of nature ever were, there was no beginning, and ever will be. So once I formulated that view, my next decision was, that's an interesting theorem, a fundamental theorem of existence that insists that there be some reality without a beginning. What are the rules of that reality? And I had already read Max Tegmark, who was a scientist who followed the cosmic microwave background. And his view was that reality is mathematical in nature. And I found that very acceptable. And then the more I looked into my inquiry into reality and realized that virtually all of physics involves relationships between fields, which is a very illusory kind of thing. And
when you say fields, you mean the fields that are used in, for example, the standard model, like the mathematical concept of a field, right?
Well, I go back to the famous words of Freeman Dyson, who, as you know, with Richard Feynman, traveled across the United States and was awarded a Nobel Prize with Richard Feynman for his work on, I think, QED. But he said, at the end of it all, it's just there are about 5 or 6 fields, and I may have his quotation wrong, but it's all fields. And whether, in our universe, it's either matter, which is we know is all fields, or it's light, which is a similar kind of field.
Okay.
So it's just relationships between things. The most efficient way of describing that has to be mathematics.
Okay.
Although mathematicians don't realize that's why they're doing their work. They're exploring new patterns. But if you're looking at reality, you simply have to look at mathematics. And I'm not a mathematician, of course, but I know some of the findings of math.
Mm.
And that's where I would look for that fundamental theorem of existence and the eternal truths, I call them the eternals,
Okay.
of reality.
Okay. So you mentioned that maths is describing things, and then you also said that there are some eternal truths. So from that perspective, is it that mathematics is a tool with which we can explore these eternal things that don't have a beginning without a big bang, or is maths the foundation with which reality arises and is constructed out of? What's your view on that?
I think math is the language that we use. It could be that there are certain truths relating to existence that are almost mathematical in origin. So, for example, take 1 + 1 = 2.
Mm-hmm.
That is going to be there, no matter what. And there are more complicated versions of that simple statement. I mean, the most gorgeous of which, of course, is Euler's identity, which involves pi e I, which is the square root of -1, and -1 itself. What an incredible combination of patterns that you see when you go into math. So it's very suggestive that some relationship between relations is there, and it's best described in mathematical language, I think. By the way, to give you another example, which comes from physics, the famous Emmy Noether, so-called Noether's theorem, is that she proved that wherever you find a conservation law, you will find a symmetry, and vice versa. So something like that could conceivably exist and compel reality. The only other thing I would say is that, if you look at 1 + 1 = 2, it's a static identity. So how do you get from that to a reality which is full of change and
dynamic? And
yeah, exactly, more
complex,
dynamic.
Yeah.
And I don't know the answer. It's something that I query. Sometimes I think maybe it's trying to find the last digit of pi.
Something like it.
But there is some kind of a random number generator. That's the other thing, of course, that you learn from quantum theory, which is that it's all probabilistic in an extremely accurate way. So the averages are within, such high degrees of accuracy that even though it's probabilistic, it's still incredibly accurate. I'm talking quantum theory, yeah.
Okay. So there's something about probabilities that even though it's random by nature, you can do stuff with it. It has like a physical nature or predictive power, maybe. Is that one way to put it?
Well, I do believe that there's at least two incredibly powerful tools from probability theory, in addition to the overall way of looking at things in terms of odds. But the one is Bayes' theorem, which allows you to take a subjective view of the probability of something, and provided that you know the posterior odds, the conditional odds that would flow from that hypothesis, you can actually work out to closer and closer degrees what the real odds, let's say, is there a God or is there not a God? That's what Bayes used.
Oh, okay.
You can work that out. You can say, well, if there's a God, then something else would happen. Maybe that's a poor example, but various other hypotheses can be tested. And by the way, Bayes' theorem is used in sampling theory as well.
Yeah.
So Bayes is very strong, I think, based on the ideas of conditional probability. And the other one is sampling theory. I spent a lot of time using sampling theory, both parametric statistics using the normal distribution and non-parametric statistics, where you would use maybe a binomial distribution or something like that to work out the odds of a sample being, to work out the odds of a population based on the sample. So the extraordinary thing there is that whether you have a population of 1 million or 50 trillion, your sample of 200 is going to be pretty much the same accuracy. It doesn't depend on the size of the population, except for small populations. It depends on the size of the sample, and that's entirely based on probability theory.
Okay, so this idea of sampling theory you were using quite practically in terms of doing surveys and trying to get an understanding of what people think, I guess. Is that the practical applications?
Yeah. I spent a lot of time doing survey research in the marketing and advertising business, and we used whatever techniques we could find out there, using various models, including models of correlation and so forth. But the essence of it was we would say, hey, I can tell you pretty confidently that the population will prefer this product to that product, even though I've only spoken to 200 people. Yeah.
Interesting. So isn't that quite interesting that you can take something like human nature, which is a very complicated, emergent, dynamic phenomena that many people struggle to even understand one other human.
Yeah.
But when you aggregate and maybe leverage some of these concepts like the law of large numbers, you can actually extract pretty predictive measures of what a group of people are going to do, which you can almost never do for a single person.
I don't think that's entirely accurate. In market research anyway, we spent a lot of time figuring out what questions do you ask, how do you get at what the human being is thinking, and of course, if your main consideration is purchase decisions, very often that's done on a very casual basis. And the idea that people think hard and say, do I want this washing powder or that washing powder is simply not real. And so therefore you had to structure the context of the questioning so that it was as close as possible to the real situation.
So not appealing to logic too much, because then they feel like they're trying to pass an exam and will try to be very analytical, when
exactly.
in reality they don't actually
and sometimes
do that.
Trying to please you. And so you'd have to design little things to check out where that was. And whenever possible, you would try and do comparisons. So you'd have a lodestar to measure your results by. But I don't think you can get close to understanding human nature using sampling theory.
Interesting. Okay.
You can only understand what the whole population, the whole economy is up to, the whole of Wall Street is up to, based on the averages. You're looking for an average usually. So it's not very clever at getting into the fundamentals of thinking. It's getting into, but it can get into the fundamentals of behavior.
Behavior of a group.
Behavior of a group, yeah.
Okay.
So, for example, you might have a new product and you might try and test this new product in as realistic a way as possible amongst 1,000 respondents.
Okay.
And now you get a very accurate idea of their behavior. But as to the reason for their behavior, I don't think sampling theory is going to add anything to that difficulty.
that makes sense. So back to where you got this interest for trying to get to reality. Do you think it's there's a deeper question that you're trying to resolve, or was it just a natural affinity to mathematics and analytics, and just as an intellectual stimulation that drew you into trying to understand more about it and do so much reading?
Well, a huge stimulation to me. I went to a course at Vassar called 20th Century Revolutions in Science. And that was divided into certain categories, which I've basically adopted. The textbook for that was Griffith, who is well known to science students. And it runs through special relativity. And what I discovered, of course, I learned the special relativity, which is fairly simple. It's Euclidean in nature. Anyone could read it. Never taught to me, which makes me very angry, why physics teachers are not talking about some of these truths. But anyway, it was many, many years later that I reflected on the fact that Einstein's special relativity, which basically says that things change when you're at relative speed, and which is based on an assumption of a fixed speed of light, when I suddenly thought, holy smoke, all our world, which consists of measurement, objects with a certain physical dimension, time, have been totally turned on their head by this theory, so that time is no longer a solid absolute thing. There are other reasons for questioning time as in that way. But then finally he came up with this extraordinary view, and by the way, he based it simply on logic, on the theory of conservation of energy, which is held as almost biblical by physicists. And once he applied that to special relativity, he discovered that there was an equivalence between mass and energy. And I find that an extraordinary result. Later on, I came to discover that there is no such thing, in the normal meaning of the word thing, there's no such thing as energy. It's just an auditing concept.
Okay.
It's just a measure. But nonetheless, what it says, what Einstein said there, I thought was remarkable, which helped me to try and figure out what happened in the Big Bang, our little Big Bang, which was that there was a huge amount of energy which eventually coalesced into matter in the form of flying particles, which balanced each other out in atoms. To start with, there were only hydrogen atoms, of course, and maybe a little bit of helium, but that's how I think energy equals mass. And by the way, this has been established, there's no question about this, is that when you use up some energy, you find there's a reduction in mass. So anyway, those three things came from special relativity. This fairly simple Euclidean logic about relative speed. And then I went on to their next chapter, which was quantum physics, and then cosmology. I kind of ducked particle physics because I thought that would just be boring with zillions of different mesons and bosons and what have you. But I think that was a mistake, because actually particle physics was really the basement thinking for the standard model that we now believe in. I took a look at thermodynamics and the second law of thermodynamics. Because I had been accused by Lord Snow and Lord Kelvin of being a complete idiot if I didn't understand the second law of thermodynamics.
Was there anything interesting in the second law that, from your own reading of it, what do you think causes this increase in entropy? What is the meaning behind that? Why has this happened?
Well, here's the journey I went on. I took the basic model as being a gas with molecules bumping into each other.
Sure.
So I had a look at collision theory, and every time there's a collision, let's say you have a faster object, molecule, colliding with a slower one, what happens is that they average out.
Okay.
The faster one gives up some of its energy, the slower one gains energy, and of course you've got conservation of energy or momentum.
Yeah.
And so when I looked at collision theory, I said, well, this is just an averaging process from the interactions of collisions. But then I started thinking, and I said, well, hang on a second. If we're talking about increasing disorder within a system, how come all the galaxies are examples of coalescing matter? That's not increasing disorder, that's increasing order.
Seems like it, sure, yeah.
Yeah, and the whole universe is doing that from this thing called, gravitational force. And then, of course, another question that arises is, if the second law is always working, how the hell did you get this very, very intense singularity at the beginning of the Big Bang?
Sure. Yeah.
That seems to be a violation.
Bit of a contradiction.
But of course, we don't know whether our level of scale is we know it's not the only one.
Sure.
But we look down as far as we can. We say 10 to the minus 36, somewhere around there, somewhere around the Planck scale.
Yeah.
And then you look up and you get, there are apparently hundreds of billions of galaxies. The scale of the size of the universe is, say, 30 million light years, 30 billion light years, sorry.
Yeah.
But who's to say that you couldn't just quadruple or multiply all those scales by an infinite number? There's no reason why one scale has to be privileged. And so we can't be sure. And of course, we go by what we see and what we're used to. So, as far as I can see, there is, by the way, the second law is, once I looked into it, and by the way, I urge you to go and have a look at the definition of the second law and try it out yourself.
Yeah.
It's a state of disorder of the various components of a system.
Yeah.
But what you'll find out is that the second law is not a surefire law of causative effect. It's a probabilistic law.
Yeah.
It's a statistical law.
Mm.
It says that it's very likely that disorder will increase.
Yeah. It's likely. Yeah. It's probable.
So again, we have the re-emergence of probability.
Yeah, and uncertainty. So you've mentioned now that kind of one of your principal almost aesthetic appeals was your refusal to accept that there wasn't a beginning, and that you would like to have things or figure things out as if that was a given, and kind of like reason about it from there, which is quite nice. And I think that's a benefit to science, to take sort of a given axiom or an accepted axiom, take the opposite of it and see where these investigations lead. It's pretty interesting. I also think it's useful in terms of reasoning about things from these perspectives. And I wanted to see if you had any similar ideas or maybe helpful ideas with regards to that, in terms of what we're experiencing at the moment with the advent of AI and the advent of what seems to be intelligence in machines for the first time, and this kind of like human experience of having to deal with things that for the longest time seem to be only what people like us would be able to experience, other humans, that is. And is there anything that you can see from physics or these laws of statistics or these this experience that you have with actually really being at the coalface of sampling theory and that sort of thing, that can inform our understanding or potentially ideas about how to deal with a future world where AI might be not just prolific, but potentially smarter than us or ever present in our lives, and might lead to something where the bigger question here is, if there's no beginning, is it possible that there's an end? And if there is no end, could there be an end to humanity with the superintelligence at least?
Well, no doubt that there could be an end to humanity. My view is that humans are not that important, although I do deal with that in my investigation as to whether life is significant.
Mm-hmm.
I think I've told you, I think in my inquiry there came up with a question, which is, why is the life on our planet written only in one code? That's very peculiar. If life is so determined to seek out every little corner of advantage,
Mm-hmm.
why is it that we only have this very complex and marvelous code, the RNA DNA code?
Yeah.
But anyway, going back to AI, I was looking at the hope of AI
Mm-hmm.
very early on when I was studying economics.
Okay.
There was a guy called Herbert Simon. I don't know whether you've ever heard of him. And they had been trying and trying and trying to somehow apply artificial intelligence. So when I heard, and they'd failed,
Okay.
and I don't even know if Herbert Simon is still alive. He came at it from an economics point of view, but they had been struggling. So when I heard the tremendous success, both on the stock market and in the news and everywhere else about the success of AI, I thought, this is amazing.
Okay.
How the hell, what is going on here? Now, I'm not an AI expert, obviously. I've heard people talk about it, including some of those English experts. And the debates about whether AI is going to make us all redundant. My view is that, and I am a bit cynical, is that AI appears to me to take a database, typically a human database, and draw patterns from that database. These are monstrously large databases, which no human on their own could possibly examine in the same way, and presumably deduce from them certain, in tremendously subtle ways, the ability to converse with a human being about a certain result. So I guess my suspicion is I would want to know a lot more about the human database. I guess it doesn't have to be human, but anyway, what the database was that was the consultative basis for the conclusions.
Yeah.
My second concern is you can't analyze the logic of it, I don't think. Maybe you can tease out in the software which patterns were discovered and what the algorithm was, or algorithms that came across that pattern, and maybe give yourself a little bit more confidence. I know there's been tremendous success in medicine, for example, in just taking the results of breast cancer and applying AI to those. And they have been proven to be a lot more successful. But even then, if I was a doctor, I would want to know, I would want to cross-check that with the fear that there was a logical component in the algorithm that didn't quite suit the circumstances of my, patient who might be having, let's say, leprosy at the same time. Anyway.
That's interesting. So, in other words, what you're saying is you would feel better as a human that there was some logic that you could extract out of whatever the machine is doing in this complicated, sampling of reality or analyzing of data, which is just a subset of reality, I guess. Is it possible that logic is maybe a human thing, or our interpretation of logic? Because it's just a machine at the end of the day, and if the scale gets to a point where it's figuring something out, and the logical components, might just be us trying to read something into it that's impossible. Maybe it's just at those numbers, it's too big to ever extract logic.
Well, here's the essence of it. If I said to you, it's going to be a perfect day tomorrow, and you said, how do you know? And I said, trust me.
Yes, exactly.
So the question of the level of trust. Now, that doesn't mean you can't say, well, we've used this machine and its accuracy rate is 99.999, and I saw those results. I might say, this is a machine I want to use.
Okay.
But nonetheless, it surely has to be, your first question is, what's the algorithm? Give me some kind of sense of the algorithm, and give me some sort of sense of the population you're drawing from.
So the analogy there would be, why does it not make you feel as uncomfortable that it's as hard to extract logic out of things like DNA and RNA and these natural, almost maybe more complex dynamics? So going down or going backwards in evolution, it's difficult to extract logic, and then going potentially what you could consider forwards in evolution, with AI, if you consider that as an extension of our evolution, it's hard to get logic out there. Are we just maybe in this Goldilocks section right now where what's logic to us is just easy to extract from other people and what we're doing, because we're in that nice easy middle space where logic makes sense?
Logic is what?
Where logic makes sense. Because
makes sense.
If you look at genetics,
you're questioning logic. Well, remember what I said at the very beginning is that I refuse to throw away my logic. It's all I got.
Okay.
So, yeah, you have every right to question the type of logic. But I think, you had Aristotelian logic in the early days, undistributed middle and all that sort of stuff. I think today, with the existence of huge data sets that people are manipulating and drawing conclusions from, particularly in marketing, I think that I simply think you have to be a bit cynical, but nonetheless, there are new logics which incorporate statistical theory to some degree. So, for example, a lot of our conclusions as humans are based on just a simple, crude correlation.
Yeah.
And so you can, at least with your doctor, be just as cynical as you like, because you know that he's as fallible as you are. I don't think we'll get to the stage where human beings will just say, oh, it's AI, because there are obviously many different types of AI.
Yeah.
And each form of AI, GPT-3 or 4 or whatever it is, will have to sell itself in terms of its useful power. I'm not totally against it. I'm just saying I don't see how it can be a solution to all problems unless you know the logic or the algorithm, and unless you know the base of its data,
where it's coming from. Yeah, that makes a lot of sense. Are there big next questions that you are still pondering? What are the most interesting unknowns for you that you would still like to have a logical understanding of? What's next after your first draft of the meaning of reality?
Well, the last chapter is, I think, quite an interesting one, which is, what is intelligence? I've got two questions about intelligence. The one is, do we have a good enough brain to understand reality if it is presented to us.
Yeah.
And of course, we feel that, oh yeah, I could understand that.
Yeah.
But are you able to hold, let's say, 25 variables that are dynamic in your mind at the same time? Because there are portions of reality where that may be called for.
Sure.
Maybe you could understand it in the way that somebody understands a full orchestra playing music, where you may not necessarily know it's the oboes here and the trumpets there, but the full sound gives you a sense of where it's going.
Mm.
But I don't think that's quite enough. So I'm not sure whether we do have, even with the assistance of computer-aided tools, to fully understand reality if it's presented to us. Remember, there's a possibility that there are many variables we're not even aware of.
Sure.
There's a good example of one. We know there's dark matter,
Mm-hmm.
but we have no sensory input on that whatsoever.
Yeah.
So I think the jury is very much out on whether we could actually understand it. So the next question regarding intelligence,
Mm-hmm.
That first one is, do we have enough intelligence?
Yeah.
The next question is, well, if we were to look around and compare our intelligence with other forms of intelligence, how do you define intelligence?
Yeah.
There was a view put out by one of the great high-tech guys that the whole universe is a form of intelligence. So that forces you to say, well, what is intelligence?
Yeah.
And I define it as follows. An intelligent system, because I don't insist that it be live like humans are.
Yeah.
An intelligent system takes a wide variety of input and then spits out a solution, and that solution maybe could have just as many varieties of output.
Okay.
So where do we look for that? You look at the universe, and I don't see that kind of systemic ordering of results that makes me think that the universe satisfies my definition of intelligence.
Okay.
So then you might go, if you've read E.O. Wilson, he wrote a number of books, and he is a big believer in societies of animals, ant colonies, bee colonies, and he includes humans, where you have a collaborative, ordered response to threats and so forth. And I think that's quite significant. But if human intelligence is a 10, I would put an ant colony at about a 5 because it simply lacks certain key knowledge advantages.
Okay.
And the ability, certain logical systems and algorithms don't think it really has, brilliant as it is.
Yeah.
So
aren't we putting ourselves in the center of it then?
Sorry?
Are we not putting ourselves in the center at saying we're a 10? Is there anything that's higher than 10?
That higher than us? No, I do believe there is something higher than us.
Okay.
Something that takes in millions of inputs and with a genius system sorts them out and has millions of outputs. It's a system. It's not like a black box of deliberation.
Yeah.
It's a system. That system relies on a coding of information, and it rewards correct deliberations, you might say, with increase in population size. So what am I talking about? I'm talking about the system of Darwinian evolution, which to me is spectacularly more intelligent than we are.
Interesting. Okay.
Every species on Earth, and it's got some limitations. For example, it only rewards success by increasing population, and it doesn't do so, immediately. It takes a couple of generations to work, but it's got this. That system has a necessary and very valuable component, which is the genetic atoms of its feelers out there, shall we say. That DNA system has to be at least repeatable for 98% of the time, and variable to some degree, for 2% of the time. I pluck those numbers out of the air. I know that a genealogist would disagree with me.
Okay.
But anyway, what I'm saying is this marvelous system, which of course has seen the destruction of all kinds of species.
Yeah.
And yet somehow we have a planet with billions of species, all fighting away. Anyway, so I think that if that's my definition of intelligence, and I think living right with us on Earth is that system which is as ruthlessly competent as any intelligent system you'll ever come across.
And would AI fall into this Darwinian evolution system? Would it be part of it, or just an
it could be
extension
part of it.
Yeah.
Because with our own intelligence, we have this ability to multiply our intelligence. We've already done that with computers. I presume that AI is necessarily computer driven. Is that true?
For now, that's the only mechanism. It's the only substrate that we've been able to recreate this seemingly intelligent responses to our data.
Yeah.
So the hardware layer is an important factor there. Like you're saying, genetics or DNA is kind of the encoding of this Darwinian system, or at least for humans, and mammals and that lineage of life. For AI, it seems like there is a fundamental encoding that hasn't been able to escape computer hardware yet.
Yeah, well, that's a limitation that I presume will eventually be overcome.
And are you optimistic nonetheless about the advent of a world in which the potential for super intelligent machines to decide on human fate might be out of our hands? Like, is this a concern for you in terms of it's probable and it might say there's no point in us being around anymore, or this is not the type of thing we should even be worried about?
No, I don't think we can put the genie back in the bottle, but I will tell you that, particularly in the military sphere, there are very few examples, and in the commercial sphere, where given a large enough incentive, human beings don't break the rules. And there are going to be huge temptations, because if AI has the promise that appears to be out there, particularly on the battlefield, then if you're in a flat-out war, killing enemy soldiers, they're killing you, it's going to be hard to avoid the temptation to use AI on robotic soldiers and drones and what have you. The only counterexample to that is the agreement, the international agreement, which has been broken once or twice, not to use poison gases in war.
Yeah.
And that basic contract between the nations was adhered to during the Second World War, although, of course, Hitler had experienced that and probably was really happy not make sure that no soldier ever went through that again.
Interesting.
Yeah, but no, I think there's great danger, and I don't know how you, just as are with any great technology, I think the Chinese seem to be showing a real determination in every sphere, and in many spheres they're catching up with us. I'm told that they're catching fast with AI. They're making rapid progress. So Russia has a the economy of Italy, but it has a rich motherlode of highly intelligent citizens, and I think that may be more valuable than gold or oil in the ground. So if those are our two enemies, I'm not sure that'll always be there. The real danger for us is that we get drawn into a conflict and have to start using these weapons. And why might we be drawn into a conflict? Because right now we are tied into self-defense treaties with people all over the world. The chance of us being called on, whether it's Taiwan or Ukraine or whatever, is very, very high, just like prior to First World War, where there were so many different contracts that accelerated
An all-out battle, like everyone getting involved simultaneously.
Accelerated war. Anyway.
That makes sense. I wanted to leave this final question to you as something to get your opinion on, and I appreciate your musings and summarized years of understanding in physics with a somewhat separate question, but maybe I'd appreciate your input on.
Yeah.
And that's not just what's the meaning of reality, but maybe what's the meaning of life.
Yeah, the meaning of life.
That's it.
I think that's a very human question. And I think because I regard our lives as being somewhat trivial, I regard it as a non-question. Why am I here? This is our human instinct to try and find meaning in our existence. And there is no suggestion to me that there is a higher power that would like us to absorb meaning from it. So let me give you one question. Why is it with this superior power, if it exists, that the superior power has made itself known to us? Never. Now, I know you could say, well, there's Jesus, and I think Jesus was an extraordinary human being at a very important time, but I don't think you can point to that. If that's the only evidence you can give us, Mr. Superior Power, I'm afraid I don't buy it. So I don't think there is a meaning of life other than the meanings that have been left with us through the laws of Darwinian evolution. Mm-hmm. And so let me ask you this. Your granddaughter runs up to you, James, and throws her arms around your knees.
Yes.
And says, "Oh, Jamie, you have a surge of love."
Yeah.
And so you say, "I've got to find out about this." You look into your computer algorithms, you can find no evidence of feeling. But my own view is that what you will be feeling will be the very human urge to collaborate, particularly the collaboration that we experience between parent and child. Mm-hmm. And so what you might feel is an instinct greater than all of the mechanistic computations of science, something that beats everything.
Yeah.
My view is you are feeling something that was written into your code by the Darwinian evolution of mammals.
Yeah.
And your love for your grandchild or your child will really be nothing more than a symptom of that language that was written into you for your own survival.
I see. And we're just pondered by why we're here, and we're looking for a similar reasoning for something that might not be reasonable for us to ask.
Say again?
It's not reasonable for us to ask what the meaning of something like life is, because it's not a Darwinian question. Like, we can find logic in this Darwinian process and kind of extract meaning from a child giving you love and those sorts of things, because there's almost like a logical process that you can extract out of it. But when it comes to life itself, it's not a meaningful question to ask what is the meaning of life.
Well, let me ask you this. Supposing I gave you an answer,
Yeah.
what would that answer look like?
Or maybe it would look, the answer to me would be, I would either be happy with the answer or not happy with the answer.
But give me an example of such an answer.
Well, if you take the meme culture answer, it would be the number 42. You know?
The meaning of life is the number 42, yeah. So that's why I am suspicious. I mean, of course, I don't know. But I am suspicious that question comes from a desire to feel, or an instinct to feel, that we are at the center of the universe, and therefore there must be some divine purpose. But I don't see any evidence, not that I am the person that would be the person you would send out to look for such evidence, but let me give you an example. A horse is led out every Wednesday. Why? Because Wednesday is race day.
Okay.
Right? So he looks at himself and he says, now if he's smart enough, let's suppose he had some very high horse sense.
Okay.
He would say, oh, I get this. This is race day. All right. Well, now I'm looking out and I'm looking for these strange patterns. I don't see any. I don't see any evidence of a divine or super order, other than the super order that deep physics suggests. But my view on humanity is that we are a little furry mammal, and we've had our intelligence conferred on us, very luckily, giving us the ability to deliberate.
Yeah.
But I don't think we can take it further than that, but I'm open. So I don't really regard that as a proper question, the meaning of life.
What is the biggest, most interesting question that you think an answer exists to, that you would ask?
It wouldn't be much to do with will we humans survive or not. Again, I don't view humanity as being so central to the universe. I think the biggest question for me would be explain the events surrounding the Big Bang. What was the physics? What was there had to have been pre-existing physics. The Big Bang didn't invent
mathematics itself.
Energy conservation or the rules of charge. If you look at all the things that run our universe, basically it boils down to forces. And there's two types of forces: attraction, repulsion.
Okay.
So anyway, I think that would be my biggest question.
Yeah.
I don't have any questions about the life hereafter.
Yeah.
I think that's a quaint idea, wishful thinking, like a lot of our thinking.
Yeah.
And not all that important.
Great. Well, thanks for that tour de force of logic and life and meanings of reality and life and intelligence. Let's maybe do another one in a year's time when I can think of some more prolific questions to ask you.
Okay. You've got my ruminations.
Yes, yes. I'll review and revert.
And slash it, burn it. Cut it and say this is bullshit. I don't think this is an interesting question, because the big question for me with that is anyone going to read that and find it at all interesting? It's interesting to me, but anyone else, I have no idea. And I've always thought that these ruminations should be not require specialist physics knowledge or mathematical knowledge. Maybe just enough to sort of be able to state here was a major physics finding.
Yes. Dig further. So break down all these like highly theoretic, highly abstract mathematical notations to an almost intuitional logic, something that we could grasp, and if it makes sense to somebody that doesn't have to dig that deep, that maybe indicates some kind of better truth. So if the meaning behind reality could be presented as something easy to grasp, it's more likely to be true, maybe.
Yeah. If you could come up with the form of the fundamental theorem of existence, which says there will be relations because nothing is not acceptable. Nothing would create a major problem. Nothing is impossible, in essence. That's what it says. I'd be very interested in that. I don't have any hope that I'll discover what that looks like, but I do think it's mathematical.
Yeah. That much we can agree on.
Yeah. And one of those books by Wolfram. So in my ruminations, space is nothing. Time is not the absolute we think, blah blah blah. He works on these little sort of pictograms where they have rules for moving on.
Yes.
And there's a couple of interesting. One of his discoveries was the more you go forward, the more complex it gets. And that pattern is true. The big history thinkers and everybody also, the more you go, the more complex it gets. Well, you could say, well, Simon, after what you've told me that we've been in existence for an infinite period of time, then we should be extremely complex by now. But then that's the old trap. And that trap is to think that we have been evolving from a certain spot, a beginning, until now. But if it's always been, no beginning, no end, then that tremendous instinct for us to have a beginning, it's been evolving. Of course, in our universe, we do have beginnings. We do have big bangs. But the rules, they've always been there.
I like that. Okay, well, thanks so much for your time, and to be continued.
Okay, thanks. Nice questions.
Great. Thank you.